Hey everyone, welcome back to Nature of Code in Rust and GGEZ. Today we're going to move on to example introduction.4. Gaussian distribution? I don't actually know how to properly pronounce that. But if we take a look at this animation that we're going to be creating, it's basically a normalized random number. And so that's described in the section above, but basically it means really just like a fancy bell curve. Most random numbers are going to be in the center, towards the middle, and then a few outliers towards the outside. And of course, we could generate that ourselves. However, most programming languages have the ability to generate these Gaussian numbers themselves. If we take a look at the code here, it actually suggests using the random class provided by Java to do that. However, we're going to be working in Rust. And kind of a famous in-joke, Rust doesn't even have a random number generator in the standard library. We have to go out to an external crate, rand, for that. So I was looking through the documentation for rand, and I noticed that there is a way to do like a kind of distribution across a collection of numbers. But when I was searching for like Gaussian, or the alternate name for it, according to this book, is Laplacian. Oh, my French is terrible. Even just searching for the beginning of the word just doesn't exist here. But if we search for distribution, we'll find that here, and we'll see, okay, we can sample through a distribution. We can go down, where exactly is it? It's not at the bottom here. There is somewhere, oh, it's not exactly in here. Maybe it's in sample. Oh, it's in, okay, okay, so in distributions, we can see non-uniform sampling, and they only have the Bernoulli distribution here, and if we want something else, we have to use rand distr or stat_rs. So if we head over here, I notice that there's no documentation link here, but let's go ahead and take a look at the API documentation in docs.rs for rand distr. And we want something called a normal distribution as opposed to a standard distribution. And that allows us to get this mean of, well, whatever we want and the standard deviation of whatever we want. So that's what we're going to do. And then that's going to give us the ability to create this. So let's go ahead and jump into our code and start making this. First of all, what are you upset about? Oh, right, you're not template anymore. You are there. I've already copied over the template, but pretty much everything else is standard. To begin with, we're going to want to, in cargo, we need to bring in rand. And we also need to bring in this rand distr. We'll make it the latest for each of these. And here we go. To begin with, let's go ahead and we're going to want, we don't need to do the background color. So once again, I'm just going to create a random location for where this is going to be and display it there. So we're going to have a Y, which is an F32. We're going to have an X, which is an F32. That's going to be constantly updated. And we're going to have our mesh, which is a type mesh. So when we create a new one, we don't need this background color, which means we don't need you, and we don't need you. All right, so we need to get the width and height of the entire screen. So we'll do that through drawable size, pass it in this context. And then our y we want to put right in the center. So that y is equal to height divided by 2.0, and you're going to go in here. Okay, x. Where do we want to put x? Well, I'm going to initialize it to the exact center of the screen, but it doesn't really matter because we're going to be updating it in the update function. So that x is equal to width divided by 2.0. And then we're going to create our mesh. Use a mesh builder. We're going to create a circle. In this case, we want a draw mode of fill. The point and where we want this, I'm going to put this at 0, 0. Our radius, let's have this be 10. I don't know if it really matters that much where, like how big it is. The location of the x and y is always going to be the center of the circle. Tolerance, we'll make it a real circle. And then our color, let's because we have a black background, we can make this a white color. Then we'll build you, hand it the context, and question mark that. So that will give us the x, the y, the x, and the mesh. If I don't update the x, it's going to be in the exact center of the screen, and that's going to be fine for right now. Let's go ahead and draw this out and sort of like see how it feels. So it's going to be a graphics draw. Okay, so our context, our drawable, so it's a reference to self.mesh, and our draw params. Okay, so we're going to give it a destination of self.x, self.y. So if we run this, we get that nice circle right in the middle. We do notice it's like fully bright, and we're trying to go for this look where it starts nice and like has a low opacity and then appears over time. Let's go ahead and set that up. So instead of doing white exactly like this, we're going to actually create a new color. So color new. But we can make this white still. So that's going to be 1.0, 1.0, 1.0. And then the alpha, we can do something like 0.0.1, maybe even like 0.01. I'm not exactly sure how low we want to go with this. If we don't change anything else and rerun this, yeah, there, we notice that it starts very faded out and then starts appearing. Perfect. So now we want to create our sample to sort of like have it randomly appear. Now, if we start with just our random number generator, we're going to want to have RNG here, and that's going to be a thread RNG. And I believe, according to this documentation, we're also going to want this is going to be normal, new, whatever this normal new is. So a normal. So this is going to be a essentially random. You're going to be a normal. Normal. There, like that. Oh, normal of F32. That will allow us to sort of generate all of this here. So that RNG is equal to let RNG and let random is equal to normal new. And so in this case, the book is asking us to make one. Where is it? Let's say we want a mean of 320 and a standard deviation of 60. Now, the 320 is the center horizontal pixel in a window of width 640. Well, if we take a look at our main, we've got 1920. And so they want us basically to cut that in half. So we already have our width here. So the mean can be our width divided by 2.0. And then the standard deviation, now they said 60. So like 60 pixels like to the left and right of that is where we're gonna get like outliers. Perhaps like we've got a lot more to that we can deal with. Now they have like 640. It felt like they did like they've divided by 10 almost and just went to like the base 10. So if we've got 1080, let's do like 100. Something like that. And then we're going to store you in here. Oh, and I noticed it's returning a result. So let's go ahead and unwrap that. So then we can pass in RNG and random. All right, and then in update, we're going to now update our X based upon what this wants. So if we take a look at this, we're going to we've created our new normal. We can do a normal sample, hand it RNG, and it's going to give us the value. So we're going to say self.x is going to be equal to self.random.sample. And then this can be a mutable reference to self.rng. And there is that. That should give us a new x. And let's go ahead and see what this ends up looking like. And it looks very similar to what the book is. We see all our circles start to appear and where they're appearing across the screen. It's flickering a little bit, which I think might be, we're not clearing the screen. I wonder if that's like pixels, like in between pixels, causing like weird draws. Let's get rid of some of these warnings. So we're not using either of you. Oh, that's it. That's our. We could see. I don't think we have to like clear the screen like ahead of time. I think this would work for us. Let's go ahead and I'm going to rerun this, but what I'm going to do is I'm going to try to limit our frame rate for the updates here because it might be that this is like a little bit too fast. Let's go ahead and try that. There's a trick that we can do. So we can do a while. So GGEZ has a timer struct, and off of it we can have the, I think it's check update time. You'll notice this is supposed to be met in the update loop. What this is going to do is it's going to run the update once every X number of milliseconds. Let's do context there. And our target FPS. So I want to target 60 frames per second. That means once every 16 or so milliseconds, it's going to run this update loop. Now, our computer's going to be able to run the update loop here a lot faster than like once every 16 milliseconds or so. So what's going to happen is it's going to say false, 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 true, and then run what's inside the for loop, the while loop. In game dev, the opposite is also true. If our computer just slows down and it couldn't get an update within that 16 milliseconds, the next one will run twice. Sort of like to try to keep the physics sort of working properly. So if I do that, let's see what this ends up looking like. We're still getting a bit of that flickering. But the draw is really just drawing this, placing it over there. That being said, if we were to get a snapshot of this, well, maybe it's too dim. Maybe we can try to make this less of an alpha there. It still flickers on my screen. Yeah, it's definitely flickering in the recording too. I don't know why that's happening. I wonder if it's like an engine behind the scenes where it's just having trouble drawing these sort of like alpha numbers in like Windows. I don't know if this would work better in like on a Mac or Linux. That being said, this is exactly what the book example has for the example introduction.4, the Gaussian distribution. Anyways, I'll see you in the next episode. Have a great day. Bye.